Hey everyone, and welcome back to Chapter 9, Section 9.3 now. We're going to be solving quadratic equations using the quadratic formula. So like I said in the last video, we are going to be developing a formula using this idea of completing the square. So what's the goal? Well, the goal is to solve quadratic equations. Now, your equation might not look like this to start with, but you can always write it this way: ax squared plus bx plus c equals 0, with a little bit of work. What we want is a formula that instantaneously tells us the solutions of that equation. And here it is. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So this is a pretty powerful formula because it solves everything instantaneously. You don't have to do that completing the square nonsense. You just have to plug everything into the right place in the formula. Now, what I'm going to do is go through how the formula is derived, where it comes from. It's not 100% critical to your understanding or your ability to use it, but it's always nice to know where these things come from. They're not coming out of thin air, and it really is based on completing the square. So let's take a look. All right, we start with ax squared plus bx plus c, and we do what we did in the completing the square section, and that is we want to get everything the way that we like it for completing the square. So we have ax squared plus bx, and then we're going to subtract c from both sides, so this right-hand side is going to be negative c. We factor out an a. Then what we do is divide both sides by a, so we get x squared plus b over a times x is equal to negative c over a. So to complete the square, we are going to take precisely half of the coefficient of the x term, and we are going to add the square of it to both sides. So we're going to be adding b over 2a squared to both sides. All right, to add the fractions on the right-hand side together, I need a common denominator, and it doesn't really matter what the common denominator is, so long as it is common. So I don't know what the least common multiple of a and 4a squared are necessarily, but that's okay, because I can just multiply the first fraction by 4a over 4a. Okay, and we just add those two together. All right, now we know what the left-hand side is going to factor as. I'm going to take the square root of both sides. So I don't know exactly how the right-hand side simplifies, but I do know that 4a squared at least is a perfect square. And, I can really rig the original equation up so that a is positive to begin with, which means you wouldn't need absolute values. So let's assume that we did that. All that's left to do is subtract b over 2a from both sides. And we have a common denominator, so this simplifies a little bit to the mythical quadratic formula. Ta-da! All right, let's put this guy to use. So we just have to look at the coefficients in the constant term to determine what's a, what's b, and what's c, and then we just plug everything into the formula. Since b is 10, negative b would be negative 10, plus or minus the square root of b squared, which is 100, minus 4 times a, which is 2, times c, which is 11, all over 2 times 2. Let's see if that simplifies. And this does simplify a little bit because we know that 2 is a common factor of 10, 2, and 4, so we can actually factor out a 2 from the numerator and denominator. So we get that x is equal to negative 5 plus or minus square root of 3 all over 2. So once you know the formula, it's pretty easy. Okay, we got some fractions here, might make you uncomfortable, so let's clear them by multiplying by a common denominator, and let's see what would that be. 6 would work because 6 is the LCM of 2 and 3. Alright, now we are going to get it into the form that we want it to be in, ax squared plus bx plus c, except in this case we have u. Then we just apply the formula. Signs are important, don't forget about them. And let's simplify. Great. Alright, let's see. So I'm going to have to do a little bit of work here before I can apply my formula again. So our a in this case is 1. And then we just clean it up. And that would be our solution set. Right, so you should know that in dealing with quadratic equations, there are really 3 possibilities or 3 outcomes that you could have. You could have an equation like this, where you get 2 real and distinct solutions. So if you go ahead and you use the quadratic formula on that guy, you'll get 2 answers. Meanwhile, there's only 1 real solution for this quadratic equation. And it's also possible to have a quadratic equation without any real solutions, which would really mean that they have 2 complex solutions, but we're not worrying about complex numbers. So you can just really think of it as no real solutions. So how can we tell? Well, let's look at the formula again. We have negative b plus or minus the square root of b squared minus 4ac all over 2a. The key lies in this part of the formula. So that b squared minus 4ac is called the discriminant of the quadratic equation. And it allows us to tell whether or not we have 2 solutions, 1 solution, or no solutions. Because if that quantity b squared minus 4ac, if it's positive, then we get, when we take the square root of both sides, we get plus or minus the square root of b squared minus 4ac. And that's totally okay because b squared minus 4ac is positive, so its square root is defined. B squared minus 4ac is equal to 0. Then we would have plus or minus the square root of b squared minus 4ac, except if b squared minus 4ac is equal to 0, this is actually just 0. So the part that gives you the two different solutions, the plus or minus part, becomes 0, and that's why you end up with only 1. And if it's negative, well, then you would be trying to take the square root of a negative number, which we know is not a real number. So, let's put all that together. Without solving these equations, what we're going to do is identify what kind of solutions and a number of solutions. And to do that, all we need to do is calculate the discriminant, which is b squared minus 4ac. So we get that this equation has two real solutions because that number that we end up with is positive. Since the discriminant I end up with in this case is negative, it has no real solutions. And taking a look at the last one here, since the discriminant is 0, we have one real solution. So you might be saying to yourself, my goodness, how are you supposed to make the call which is best? You know, what method do we do in what situation, right? It's kind of hard to tell when you look at a formula whether or not it's going to have a nice solution or an ugly one involving radicals. So these are basically the four methods that we already know about. The first one, factoring, we already knew from way back when. The second one that we talked about in the first section, completing the square in the second section, and now the quadratic formula. And you should also look at this as kind of a priority list. So you want to factor when you can, because that is generally the easiest and fastest thing to do. You can also do the square root property, because it's usually easy to identify. If you have like x squared equals something, then doing the square root property is pretty quick. And failing those two things, you just go right to the quadratic formula. You can safely ignore completing the square because it gives you the same outcome as a quadratic formula, it's just with extra steps. So anyway, that about does it for the quadratic formula. Next up, we are going to be solving applications of quadratic formulas.